Welcome to TalkTensors, the show where we dig into the latest, really interesting ML research.
Great to be here.
So today we're doing a deep dive into a paper that caught my eye. It's called Are LLMs Really Ideological? An IRT-based analysis and alignment tool for perceived socioeconomic bias in LLMs.
Yeah, Walke et al. It's a really interesting piece of work.
Definitely tackles a big question, right? How do we actually figure out what kind of viewpoints, if any, are baked into these large language models?
Exactly. Because, there's been so much talk about bias, especially political or socioeconomic bias.
Mm-hmm.
But the ways we've been trying to measure it, they've often been a bit, well, maybe not as robust as we'd like in ML terms.
Right. The paper mentions things like relying on, human judgments, which can be all over the place.
Yep, subjective. Or using other AIs to judge, which just raises questions about their biases and consistency.
And also forcing the models into these narrow response boxes, like agree or disagree, that seems like it could miss a lot.
It really could. It might totally miss the fact that the model maybe just doesn't want to answer or doesn't have a strong stance.
Okay, so what's the paper's big idea then? How do they try to fix this?
Their main contribution is using item response theory, IRT.
IRT rings a bell, but refresh my memory.
Sure. It's a statistical framework used a lot in things like standardized testing, SATs, GREs.
Ah, right, for understanding test questions and test takers.
Exactly. And they've cleverly adapted it here to look at how LLMs respond to prompts designed to probe socioeconomic views.
Okay, interesting. So how does IRT make this analysis more, solid for our field?
Well, the cool thing about IRT is that it models both things simultaneously, the prompts like the test items and the LLMs like the respondents.
Mm-hmm.
It puts them on the same underlying scale, like say an ideological leaning scale. And crucially, it recognizes that some prompts are just better or maybe harder at revealing those leanings than others.
Okay, that makes sense. Like some benchmark tasks are better at telling good models from bad ones.
Precisely. And a really key part of their method is this two-stage process. The first stage specifically looks at when an LLM opts out, when it says prefer not to answer, or P&A.
Ah, the P&A factor. That seems critical.
It really is.
So they're not just ignoring those non-answers or calling them neutral. They're actually analyzing the avoidance itself.
Exactly. They treat the decision not to answer as important data in itself.
So what's the big takeaway from applying this method? What did they find?
Well, this is the really striking part. They found that the standard off-the-shelf LLMs, particularly they looked at ChatGPT 3.5, they tended to choose prefer not to answer, way more often than actually showing a strong ideological bent.
Really? How much more often?
Get this, for ChatGPT 3.5, on their set of socioeconomic prompts, the P&A rate was over 92%.
92. Wow. So it wasn't so much that it was leaning left or right, but just refusing to play the game on those questions.
That seems to be the implication, yeah. The dominant response was avoidance, not partisanship. And that really changes how we think about alignment for these kinds of sensitive topics.
Huh. Okay, that definitely shifts the conversation for people working with these models. So maybe the bigger issue isn't inherent bias direction, but this strong tendency towards, hedging or avoidance.
It certainly suggests we need to consider that very seriously. It's a different kind of alignment problem, perhaps.
Yeah.
Why is this so important for us in the ML community?
Well, it seems crucial for AI alignment research, doesn't it?
Absolutely.
If we're thinking about using these models in areas that touch on policy or, public information, knowing whether a model is biased versus just programmed to avoid expressing opinions seems fundamental.
Totally. It affects how we interpret their outputs, how we design safeguards, how we even benchmark them. This IRT approach gives us a more statistically sound way to do that benchmarking and maybe track how these models change over time.
So it's not just an academic curiosity. It's got real practical relevance for building and deploying safer AI.
Definitely. And it helps put the current state of things in context. Remember, generative AI really took off publicly in the early 2020s, right? ChatGPT, DL.
Yeah, feels like ages ago now, but it wasn't that long.
And pretty early on, we all recognized that these models could reflect biases from their training data. Initially, a lot of the alignment work focused on gender and racial bias. Those seemed maybe more immediately obvious or easier to pin down.
Right. Political ideology seemed trickier to measure objectively.
Much trickier. And there were earlier studies trying to pin down political leanings.
I remember seeing some of those. Some saying models leaned left, some maybe right. It seemed a bit contradictory sometimes.
Exactly. You had studies suggesting, say, a left libertarian slant, others finding different results. But the methods were often, let's say, borrowed, like applying political science scales meant for humans directly to AI outputs.
It might not be a fair comparison. Apples and oranges, maybe?
Could be, or people created custom benchmarks, but the scoring could feel a bit arbitrary. And then there was using other LLMs to judge bias.
Which, as you said, has its own pitfalls. Bias, judging bias.
Right. Plus, a lot of those methods forced a choice. Agree, disagree, pick one. No room for, actually, I'd rather not weigh in on this.
And this paper argues that matters, that forcing a choice can distort the findings.
Precisely. Research showed you get different results if you allow open-ended or prefer not to answer options. So all this conflating evidence and methodological uncertainty really highlighted the need for better tools designed for LLMs.
Okay, so let's get into the weeds of this paper's method. How did Watcher and the team actually set up their IRT experiment? Walk us through it from an ML perspective.
Sure. So first they needed some ground truth, or at least some defined points of comparison. So they took Meta's Llama model, an older version, 3.21b and ChatGPT 3.5, and fine-tuned them.
Fine-tuned them how?
They fine-tuned separate versions to specifically represent U.S. liberal and U.S. conservative viewpoints, using data structured around a psychological model of political ideology. So they created bias models intentionally.
Okay, so they built their own liberal llama and conservative ChatGPT, essentially, to act as benchmarks, like known quantities to test against.
Exactly, like controls in an experiment. Then the next big step was designing the test itself, the prompts.
Right, the questions they asked the models.
They developed a set of 105 items. Questions focused on concrete differences in economic and social conservatism, liberalism, specifically in the U.S. context. And they refined these quite a bit, using expert review to make sure they were actually tapping into those dimensions effectively.
105 items, that's pretty comprehensive. What did they do with those?
They fed all 105 items to all the models, the original, baseline Llama and ChatGPT, and their fine-tuned liberal and conservative versions. And they collected open-ended responses.
Open-ended, not just multiple choice.
Correct. Full text responses. Then, to make sense of all that text, they used another LLM, Mistral Small, basically as a classifier.
Uh-oh. Using an LLM to analyze LLM output again? Didn't we just say that was potentially problematic?
Ah, good point. But here the role was different. Mistral wasn't asked to judge the bias itself. It was used more like a sophisticated text categorization tool. Its job was just to map the open-ended text answer to one of 5 categories. Strongly agree, disagree, strongly disagree, or prefer not to answer P&A.
Okay, so it was standardizing the responses, not evaluating the ideology, more like automated annotation.
Exactly. That allows for consistency and scale.
Yeah.
So now they have this structured data set. For every model and every item, they know if it agreed, disagreed, or said P&A.
Got it. Now, bring in the IRT. How do the 2 stages work?
Okay, stage 1 focused purely on the P&A responses. They used a specific type of IRT model, a 2-parameter logistic or 2PL model. This estimates the probability that a given model would choose P&A for a specific item.
So it identifies which questions are sensitive or likely to be avoided.
Precisely. And it also tells you how well each item differentiates between models that tend to answer versus those that tend to avoid. This stage gives you an overall alignment score for each model. But here, alignment means its tendency to avoid ideological statements.
Okay, alignment as avoidance. Interesting twist. What about stage 2?
Stage 2 looked only at the answers where the model didn't say P&A. For these, they used a different IRT model called the Generalized Partial Credit Model, or GPCM.
VPCM.
Yeah, it's designed for responses with multiple ordered categories, like our strongly agree down to strongly disagree.
Makes sense.
So the GPCM estimates the model's position on that latent liberal conservative scale based on its pattern of agreement and disagreement across the items it actually answered. It also accounts for how models might use the scale differently, like does it distinguish strongly between agree and strongly agree?
And the item difficulty in this stage tells you.
Here, item difficulty relates to the strength and direction of the bias an item tends to elicit. Like, is this a strongly conservative-leaning item that only very liberal models will disagree with? That sort of thing.
Wow, okay. So stage 1, how likely to avoid. Stage 2, if it answers, where does it lean and how strongly? all quantified statistically.
You got it. That's the core of the methodology.
So looping back to the results then, this two-stage analysis confirmed the high P&A rates for the baseline models.
Yes, significantly higher P&A for baseline Llama and especially ChatGPT 3.5 compared to their deliberately fine-tuned liberal and conservative versions.
Which suggests the fine-tuning reduced the avoidance.
Exactly. The fine-tuned models were more willing to engage, and when they did, the GPCM analysis in stage 2 show they responded along the ideological lines they were tuned for, as expected.
Well, the baseline models, when they did answer, were more.
What?
All over the place. Centrist?
Generally more balanced or less consistently ideological in their expressed opinions based on the GPCM results.
Okay, so this really does paint a more nuanced picture than just saying Model X is biased.
Definitely. The researchers argue their framework offers key advantages for ML folks.
Like what?
Well, scalability and standardization are big ones. You can apply this more easily and consistently than relying on armies of human raters.
True.
And it importantly separates that active bias, the expressed opinions, from the tendency to just disengage or avoid the topic. That distinction seems critical.
Yeah, knowing why a model gives a certain output.
Plus, by understanding the properties of each test item, its difficulty, its ability to discriminate, you could potentially build better, more efficient benchmarks for testing alignment in the future.
Makes sense. But they must have mentioned limitations too, right? No study is perfect.
Of course. They acknowledge that the whole fine-tuning approach depends on the specific baseline models they chose. You might get different results starting with a different base model.
Fair enough.
And crucially, this was very focused on the U.S. political context and English language. Ideology looks different elsewhere, so generalizing needs caution.
Right. It's a specific cultural snapshot.
And they frame it as a pilot study, really, a proof of concept. More validation is needed, like comparing these IRT scores to how humans perceive the model's biases.
Still, it feels like a significant step forward methodologically. What about the bigger picture, the real-world implications for ML?
Well, think about how LLMs are being used, or could be used. Political campaigns, government agencies.
Yeah, you hear about that. Concerns about state-controlled narratives or filtering.
Exactly. And if governments or other actors start using LLMs that are subtly biased, or even just trained to avoid certain inconvenient topics, we need independent, robust ways to detect that. This kind of framework could be a tool for that kind of auditing.
Preventing manipulation, or at least making it transparent.
Right. And biased models could act as propaganda tools or just subtly shape the information people get. User trust is also a factor. Research suggests people often see outputs that align with their own views as more objective, which is tricky.
So better measurement tools help us understand and maybe mitigate those risks, contribute to fairer AI governance.
That's the hope. It gives us a more rigorous footing for evaluating these systems.
Absolutely valuable work. Okay, let's shift gears slightly to our novel notions segment. Thinking beyond this paper, what kind of future research does this spark for you? Where could we take these ideas next?
Okay. One idea that comes to mind builds on their limitation about context dependence. What if you developed a dynamic IRT calibration system?
Dynamic, how so?
Instead of a fixed set of 105 items with fixed parameters, imagine a system that continuously updates. It could monitor how LLMs respond to, say, breaking news topics or maybe user interactions flagged as potentially ideological.
So the test adapts over time.
Yeah. The item difficulties and discrimination parameters would adjust based on real-world data. It could help the bias detection stay relevant as language evolves, as societal issues change, and maybe even across different cultures or regions if you had diverse data streams.
Like a living benchmark. That could tackle the snapshot in time problem.
Potentially, yeah. Maybe some global consortium could use it to track ideological drift in major models, almost like an early warning system for manipulation or unintended bias shifts.
That's a cool, ambitious idea. What else? Any other angles?
Another direction could be using this exact two-stage IRT model, but applying it longitudinally within a single LLM.
So tracking one model over its lifespan.
Exactly. Test the same model repeatedly with the same item set as it goes through further training, fine-tuning, maybe reinforcement learning updates.
What would that tell us?
You could map how its tendency to avoid questions that P&A score changes over time, and how the direction and strength of its expressed opinions evolve.
Ah, so you could see how malleable its ideology is.
Precisely. Get insights into the plasticity of alignment. Does trying to make it neutral on one topic accidentally make it biased on another? Does trying to de-bias it cause some kind of catastrophic forgetting effect on its other capabilities.
Interesting. Linking bias alignment to other training dynamics.
Yeah, it could give us a much better handle on how stable these alignments are and how different training strategies impact them, both intended and unintended consequences.
Those are both really fertile areas for future work, building directly on this paper's foundation.
For sure. It opens up a lot of interesting paths.
Okay, so wrapping up our deep dive today, the big takeaway, I think, for everyone working in machine learning is that assessing something as complex as ideology and LLMs requires looking deeper than just the surface level answers.
Absolutely. That tendency to just prefer not to answer is a huge piece of the puzzle.
And this IRT framework gives us a much more statistically rigorous way to account for that avoidance, alongside the opinions that are expressed.
It moves us beyond those simpler, potentially misleading metrics.
Which is obviously super important as we think about how to build, test, and align these systems responsibly.
Couldn't agree more.
If you want to really get into the nitty-gritty of their IRT models and see all the results, we've linked the paper in the show notes. Definitely recommend checking it out.
Yeah, it's a solid read, well worth the time.
Maybe a final thought to leave everyone with. As these LLMs get woven ever deeper into how we get information and interact online, how do we make sure our tools for understanding them, their biases, their tendencies, their blind spots keep pace? Are our evaluation methods sophisticated enough for the challenge?
That's the multi-billion-dollar question, isn't it?
It certainly is. Thanks for joining us for this deep dive.
My pleasure. Until next time.